Good morning and welcome to today's class. Today's class is a continuation of our previous classes on SS1 mathematics. In today's class, we shall be looking at conversion of numbers involving fractions from order bases to base 10. In our previous classes, we have looked at conversion of numbers in order bases to base 10. We have equally looked at how to convert numbers from base 10 system to order bases. So in today's class, we shall be looking at numbers involving fractions on how to convert them from order bases to base 10. And in our next class, we shall look at conversion of numbers involving fractions from base 10 to order bases. Decimals are base 10 fractions, and their place values have powers of 10, including negative numbers. That is, we have from 10 to power infinity to 10 to power 3, 10 to power 2, 10 to power 1, 10 to power 0, 10 to power minus 1, 10 to power minus 2, 10 to power minus 3, down to 10 to power minus infinity. So all these are said to be the place values of numbers in base 10. Decimals, on the other hand, are base 2 fractions, and their place values have powers of 2, including negative numbers. That is 2 to power infinity down to 2 to power 3, 2 to power 2, 2 to power 1, 2 to power 0, 2 to power minus 1, minus 2, minus 3, and down to power 2 to power minus infinity. For example, 45.683 is equivalent to, this is in base 10, expressing it as a product of its place values can be said to be 4 times 10 raised to the power of 1 plus 5 times 10 raised to the power of 0 plus 6 times 10 to power minus 1 plus 8 times 10 to power minus 2 plus 3 times 10 to power minus 3 in base 10. In the sense that this is occupying the place values of 10 to power 0. This is 10 to power 1, which makes it the 10th unit. This is said to be the 10th place value. This is said to be the unit place value. And this is said to be 10 raised to the power of minus 1, which is the 10th place value. This is said to be to the power of minus 2, which is the 100th place value. And this is said to be to the power of minus 3, which is the 1000th place value. And when you express them as a product of their place values, this is what you will get in base 10. Also, decimals can be converted to the base 10 system as shown below. We are asked to convert 101.111 base 2 to base 10. And in converting it, you express it as a product of its place values. And this is going to be, now before we do that, let's identify the place values of each digit in the number. If this is said to be place values of 0, I'm now giving the place values of the whole numbers, starting from 2 raised to the power of 0. This is 2 raised to the power of 1, and this is said to be 2 raised to the power of 2. For the fractional place values, we have minus 1, minus 2, and minus 3. So expressing them as a product of their place values, this will be now 1 times 2 raised to the power of 2 plus, I'm picking them one after the other, 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0 plus, now to the fractional part, 1 times 2 raised to the power of minus 1 plus 1 times 2 raised to the power of minus 2 plus 1 times 2 raised to the power of minus 3. We can now simplify them and get our answer. This can be represented as 1 times 2 to the power 2 is 4 plus 0 times 2 plus 1 times 1, because 2 raised to the power of 0 is said to be 1, plus 1 times 2 raised to the power of minus 2 is said to be 1 over 2, plus 1 times 2 raised to the power of minus 2 is said to be 1 over 2 squared, plus 1 times 2 raised to the power of minus 3 is said to be 1 over 2 cubed. I'm going to simplify them further to be equal to 1 times 4 is 4 plus 0 times 2 is 0 plus 1 times 1 is 1 plus 1 times half is half plus 1 times 1 over 2 squared. 2 squared is said to be 4. So this becomes 1 over 4. And 1 over 4 times 1 gives us 1 over 4 plus 1 over 2 to power 3 is said to be 8. Simplifying this further, you have 4 plus 1 is 5. So I have 5 whole number plus 1 over 2 plus 1 over 4 plus 1 over 8. You can then look for the LCM. The LCM of this is 8. 2 into 8 is 4. 4 times 1 is 4 plus 4 into 8 is 2. 2 times 1 is 2 plus 8 into 8 is 1. 1 times 1 is 1. So our answer now is said to be 5 whole number, or 5 plus, this is 677 over 8. Now we have to convert this to fraction. This is equal to 5 whole number 7 over 8. But as decimals, you have to divide 7 by 8. And 7 divided by 8 is said to be 0.875. So our answer is said to be 5.875, all in base 10. So 101.112 is said to be 5.875 in base 10. Kindly like our videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the link with your friends and family so that they can also benefit from this project. We shall then take another example, example 2, that we should convert 1.011 base 2 to base 10. So this is equivalent to 1.011 base 2. Writing their place values, this is said to be of zeros. This is -1, -2, and -3. This becomes 1 times 2 raised to the power of 0 plus 0 times 2 raised to the power of -1 plus 1 times 2 raised to the power of -2 plus 1 times 2 raised to the power of -3. So this is equal to 1 times 1 plus 0 times half plus 1 times 1 over 2 squared plus 1 times 1 over 2 cubed. Simplifying this further, this is equal to 1 times 1 is 1 plus 0 times half is 0 plus, this is 1 over 4 times 1 is 1 over 4 plus 1 over 8. This is equal to, you then add 1 plus, let's sum up the fractional part, LCM is 8, and this becomes 4 into 8 is 2, 2 times 1 is 2, plus 8 into 8 is 1, 1 times 1 is 1. This becomes 1 plus 3 over 8, which is equal to 1 plus 3 divided by 8 gives us 0.375. And when added together, it becomes 1.375 in base 10. So 1.011 in base 2 is said to be equivalent to 1.375 in base 10. Example 2, we are asked to convert 14.311 base 5 to base 10. You do same as what I have done in the first two examples, 14.311 base 5. This is occupying the place values of 5 raised to the power of 0, 5 raised to the power of 1. This is 5 raised to the power of minus 1, minus 2, and minus 3. So, expressing them in the expanded form, you have 1 times 5 raised to the power of 1 plus 4 times 5 raised to the power of 0 plus 3 times 5 raised to the power of minus 1 plus 1 times 5 raised to the power of minus 2 plus 1 times 5 raised to the power of minus 3. Simplifying this further, this is going to be equal to 5 raised to the power of 1 is said to be 5 times 1 is 5 plus 5 raised to the power of 0 is 1 times 4 is 4 plus 3 to power 5 to power minus 1 is 1 over 5. So 1 over 5 times 3 is 3 over 5 plus 2 to power minus 2 is said to be 1 over 25. And 1 over 25 times 1 is 1 over 25 plus 5 to power minus 3 is said to be 1 over 5 raised to the power of 3. And 5 raised to the power of minus 3 is said to be 1 over 5 cubed. And 5 cubed is 125. So that means 1 over 125 times 1 gives us 1 over 125. This is equal to, add up the whole number part, we have 9 plus, find the LCM of 5, 25, 125 is said to be 125. 5 into 125 gives us 25 times, and 25 times 3 is said to be 75 plus 25 into 125 is 5. 5 times 1 is 5 plus 125 into 125 is 1. 1 times 1 is 1. So this is equal to 9 plus 75 plus 5 is 80 plus 1 is 81 divided by 125. This is equal to 9 plus 81 divided by 125 gives us 0.648. 0.648, and this is equal to 9.648. So 14.3115 in base 5 is equivalent to 9.648 in base 10. We take the next example. Example 3, we have to convert 21.123 to base 10. This is 21.123 in base 10. Place values of 0, 1, minus 1, and minus 2. In expanded form, this is equal to 2 times 3 raised to the power of 1 plus 1 times 3 raised to the power of 0 plus 1 times 3 raised to the power of minus 1 plus 2 times 3 raised to the power of minus 2. Simplifying this further, this gives you 2 times 3 plus 1 times 1 plus 1 times 1 over 3 plus 2 times 1 over 3 squared. This gives us 2 times 3 is 6 plus 1 times 1 is 1 plus 1 times 1 over 3 is 1 over 3 plus this is 3 squared. 3 squared is 9. That is 1 over 9. 1 over 9 times 2 is 2 over 9. Summing this, 6 plus 1 is 7 plus, find the LCM of 3 and 9. I'm adding the fractional part. This gives us LCM is 9. 3 into 9 is 3. 3 times 1 is 3 plus 9 into 9 is 1. 1 times 2 is 2. So this is equal to 7 plus 5 divided by 9. This is equal to 7 plus 5 divided by 9 is approximately 0.556. And when you sum them up together, this gives you 7.556. as your answer. That brings us to the end of today's class. In today's class, we have been able to look at conversion of numbers involving fractions from other bases to base 10. Subsequently, we shall be looking at how to convert numbers involving fractions from base 10 back to other bases. But before I go, I will leave you with this assignment. You are to express 1.011 base 2 in decimal notation, which I have taught you. Get out, identify their place values, and then just multiply each of the digits by its place values. That is what is expected of you to do. Exercise 2, you are asked to arrange the following decimals in descending order. So you have to identify which of them is the greatest and arrange them in the order of decreasing numbers. And we are asked to hence find their decimal equivalent. What I would advise you do is to first of all convert each of them to base 10. Thereafter, that will inform you on which is greater. Then you arrange them in either ABC or BCA or CAB, whichever way it is. Kindly like my videos as you watch. Why I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the link with your friends and families so that they can also benefit from this project. You can also follow us on our daily classes, live stream, where we meet every day by 7 p.m. to 9 p.m. on YouTube, Facebook, and on TikTok. Thank you and do have a nice day. See you in our next class.